Hello, my dear students of Benguet State University. Welcome to our online class. I am your teacher, Jan Lasea.
Ladies and gentlemen, a blessed day to everyone. This is my second lecture on our subject, IT 128, Quantitative Methods. Let us understand word problems as essential for developing a computational model or mathematical model. Although a computational problem may be solved using mathematics, a calculator, or a computer program, developing a solution to these problems begins with a description of the problem in a human language, such as English. To solve such problems, it is necessary to understand what the English problem statement is saying. One may say, well, I already understand English, and that is correct for casual conversations. In this case, one only needs to have a general understanding of what is being said. The problem statement of real-world situations is often described in a very ambiguous, incomplete, and confusing manner. However, for developing computational models from problem statements, one needs to understand precisely what is being said. Therefore, there is a need to focus on every word that is being said, not just the general context. Otherwise, the appropriate computations will most likely not to be performed. Nouns and verbs. Consider the following English problem statement. To calculate the area of a rectangle, multiply the width and height. The key to understanding a word problem is to find the nouns and the verbs. The nouns that we can find in the statement are area, rectangle, width, and height. The verbs that we can find in that statement are calculate and multiply. Diagram is useful to visualize and understand much better the idea, requirement, and concept of the statement. The symbol rectangle or square indicates the noun, and the symbol oblong, circle, or ellipse indicates the verb. The arrow indicates direction, uses, and produces. To read or interpret the diagram, we say the width and height are used by times operation, then it produces the area. Once we know what the nouns and verbs are, we can understand the computation by understanding how the values we have are used and what values are produced. Once we understand that, then it is easy to create a formula for the problem. The formula area is equal to width multiplied by height. The X indicates the verb times, and the equal symbol indicates the verb calculate. Now consider a more complicated example. Calculate the energy needed to heat water from an initial temperature to a final temperature. The formula to compute the energy is the amount of water in kilograms times the difference of the final and initial temperatures in Celsius times 4,184. In the statements, I highlighted in bold text the words that are verbs, while the nouns are highlighted in underlined text. The nouns are energy, water, initial temperature, final temperature, formula, energy, amount, difference, and 4,184. The verbs are calculate, hit, compute, and times. From the gathered nouns and verbs, I drew this diagram. And we can read and interpret the meaning of this diagram. The initial temperature and final temperature are used by subtract operation and produces the difference. The difference and amount are used by the times operation and produces the product. The product and 4,184 are used by the times operation and produces energy. We learn PEMDAS in elementary mathematics. It is an order of operations agreement. The direction of order is from left to right. PEMDAS means that parenthesized expressions are computed first, followed by exponents, followed by multiplications and divisions, whichever come first, followed by additions and subtractions, whichever come first. On the diagram, the direction of the arrows are from left going to the right. Subtract will be first computed, followed by times, followed by times. On the computational model or mathematical model, we see the expression final temperature minus initial temperature is parenthesized. That means it will be first computed, followed by times, followed by times. Therefore, our diagram and computational model must agree with PEMDAS. Here is your assignment. For problems 1 and 2, identify the nouns and verbs and then create a diagram showing the calculations from a formulated formula. Number 1. The area of a regular hexagon is 3 halves times the square root of 3 times the square of the length of a side. Number 2. Phil has 5 quarters, 3 dimes, and 2 pennies. How much money does he have? Number 3. Find the value of x in this equation. 3 raised to x plus 1 is equal to 81. And problem number 4. Find the value of x in this equation. 3 raised to x squared minus 7 is equal to 27 raised to 2x. I posted your second assignment in our Google Classroom. Please answer and accomplish it.
That ends our topic for today. I hope you have learned in my class. Thank you for watching. Carry on until tomorrow. God bless us.